In this section, we'll dive into automations, terminal workflows, and GitHub systems. We'll explore how advanced Claude code and AI agents can be leveraged to build powerful applications, streamline automations, and enhance developer workflows. This will equip you with practical tools and techniques to improve efficiency and productivity in your development processes. Developer automation is all about streamlining and simplifying the tasks that developers routinely perform. At its core, it involves automating repeated tasks, which means that instead of doing the same manual steps over and over again, the process handles them automatically. This not only reduces manual effort, but also helps create workflows that are consistent and reliable every time they run. By automating these steps, developers can save a significant amount of time, allowing them to focus on more complex and creative aspects of their work. Additionally, automation improves the overall quality of the software by minimizing human errors. In this context, advanced tools like Claude Code and AI agents play a key role, enabling smarter and more efficient automation that adapts to different development environments and tasks. When deciding what to automate, it's essential to focus on tasks that are repeated frequently and follow clear, rule-based processes. These are the best candidates for automation because they happen over and over, often taking up a lot of manual effort. For example, activities like file changes, running tests, creating builds, updating documentation, preparing release notes, generating reports, and reviewing logs are all prime targets. By automating these kinds of repetitive tasks, you not only save time, but also reduce the chance of human error, making your workflow much more efficient. Starting with these areas allows you to leverage automation where it will have the biggest impact. When it comes to automation, it's important to use it carefully and thoughtfully. Not everything should be fully automated, especially when high-impact actions are involved. These actions should always keep a person in the loop to ensure proper judgment and control. Expert automation isn't about removing responsibility. Instead, it adds control points where humans can intervene. For example, production deployments should never happen without a thorough review before anything reaches live users. This helps prevent mistakes that could affect customers. Similarly, database deletions are critical and should never occur without explicit approval, since data loss can be severe. Security changes, including modifications to permissions, secrets, and policies, require careful human review because these decisions have major implications. Payment systems also demand tight control. Any movement of money or billing logic should be closely monitored and controlled by humans to avoid errors or fraud. Handling user data, especially personal and private information, must include strong checks and limits to protect privacy. Finally, when it comes to legal decisions, the judgment and compliance responsibilities should never be handed over automation. These matters require a human touch to interpret laws and regulations correctly. In summary, while automation can boost efficiency, we must implement it with caution and keep humans engaged where decisions have significant impact. Here, we have an automation workflow map that breaks down the entire process into 6 clear stages. It starts with the input phase, where files, requests, or triggers initiate the workflow. Then we move into processing, which involves checks, parsing, and applying logic to the input data. Following that is the action stage, where the system runs specific commands or tasks based on the process information. Next, we come to the review phase. This is crucial because it's where human approval or intervention can be added, especially at points where risk is higher. After review, we reach the output stage. This is where results, reports, or changes are generated as the outcome of the workflow. Finally, the documentation stage captures all the steps taken, logs created, and standard operating procedures followed to ensure everything is recorded for future use. The key takeaway is to define your entire path clearly before automating anything. Incorporate reviews at any point where you anticipate risk, and always document your outputs thoroughly so they can be reused and referenced later. This structured approach helps keep automation efficient and reliable. Before diving into automation, it's crucial to validate the task itself, assess the risks involved, and identify control points. First, ask if the task is repetitive. Automations work best when the same task happens over and over. Next, is the task rule-based? Clear, defined steps are essential to ensure the automation runs reliably. Consider what could go wrong by identifying potential failures before you build the workflow, so you can plan safeguards. Also, determine where human approval is necessary. Keeping reviews for sensitive or high impact actions helps maintain control and accuracy. Finally, think about how you will verify success. Define checks, outputs, and evidence that the automation functioned as intended. By following this mindset checklist, you set yourself up for effective and trustworthy automation solutions. Here, we're looking at why terminal workflows are so important for developers. First, developers are already comfortable using the terminal, so integrating workflows there feels natural and intuitive. Second, working directly in the terminal allows for faster project navigation, cutting down on time spent clicking through files or menus. Third, you can execute commands directly without switching context, which boosts productivity. Fourth, the terminal seamlessly works with essential tools like Git, scripts, and tests, making it a versatile environment. Finally, terminal workflows are ideal for integrating with advanced AI like Claude, enhancing coding and automation through powerful AI agents. All of these factors combine to make terminal workflows a critical part of an efficient development process. Now, let's talk about terminal productivity and some of the most common tasks that developers perform in the terminal. These include listing files to see what's in your current directory, searching through code to quickly find specific functions or variables, and running applications directly from the command line. You can also run tests to ensure your code is working as expected, install packages to add new functionality or dependencies, check the status of your Git repositories to keep track of changes, and read logs to diagnose issues or monitor system behavior. Beyond these basic tasks, advanced tools like Claude Code and AI agents can help you build applications, automate repetitive workflows, and enhance your overall developer productivity. These tools are designed to streamline complex processes and make coding more efficient and effective. When working with AI-generated terminal commands, it's crucial to ask Claude or any AI assistant to explain the commands before running them. Use explanation-first prompts like asking, "Explain what this command does, what files it affects, and whether it's safe to run in this project." This practice helps you understand the purpose and potential impact of command, reducing the risk of unintended consequences. Always review these explanations carefully to make sure the command is appropriate for your project and safe to execute. This habit of reviewing before executing is a practical safety measure, especially when using advanced AI agents like Claude for coding tasks. In this section, we're focusing on creating a terminal command library to streamline your workflow. The idea is to save the commands you use repeatedly, which helps keep project setup, testing, building, and recovery fast and consistent. For example, you might start with a command to initialize or start your project, followed by commands to run tests to ensure everything is functioning correctly. Next, you have commands to build a project, which compiles your code and prepares it for deployment. You also want to check formatting, making sure your code meets style guidelines, and check log for any errors or important messages. When it comes to deployment, having a command that deploys safely ensures you can roll out updates without disruptions. Lastly, cleaning temporary files with command helps keep your environment tidy and manageable. By organizing these commands into a library, you make your terminal workflows much more efficient and reliable. When working with terminal commands, it's crucial to follow a consistent workflow checklist to avoid costly mistakes. First, controlled speed is better than risky speed. That means you should take your time to perform the same checks every single time before running, saving, or reusing any commands. Always make sure you fully understand what the command does. Running a command without understanding it can lead to unexpected results. Next, ensure you are in the correct folder or directory before executing the command, as running it in the wrong location can cause problems. Avoid using risky flags or options unless you are absolutely sure their effects. After running the command, carefully check the output to confirm it behaved as expected. If you find commands that are especially useful, save them for future use to save time. Finally, document any errors or issues you encounter to help troubleshoot or improve future workflows. Following these steps will make your work with advanced Claude Code and AI agents much safer and more effective. Let's talk about what a reusable command workflow is. Essentially, it's a repeatable process that you can apply across different projects. This means once you set it up, you don't have to start from scratch every time, which save a lot of setup time. Not only does this efficiency help you get things done faster, but it also reduces mistakes because you're using a proven process each time. Another key benefit is that it creates consistency, ensuring that outputs are reliable and standardized. This slide also touches on how advanced tools like Claude Code and AI agents can help build these workflows, automations, and developer processes, making your work more streamlined and powerful. Let's walk through an example workflow for a pre-commit check that ensures every commit is reliable and consistent. It starts with 6 essential steps that you should follow every time. First, check the Git status to see the current state of your working directory and stage changes. This helps you understand what files you're working with. Next, run the formatter. This step automatically formats your code according to project style guidelines, keeping everything neat and consistent. After that, run the linter. Linters catch syntax errors and enforce coding standards, preventing problems before they get into your commit. Then run tests. This is crucial. It verifies that your changes don't break existing functionality or introduce bugs. Fifth, review the change files carefully. Double-check the code you're about to commit and make sure everything looks right and is as intended. Finally, write a clear and concise commit message. A good commit message explains what was changed and why, which is invaluable for your team and future reference. By consistently following these 6 steps, you can maintain a high-quality code base and avoid common issues that arise from unreliable commits. Here, we have an example of a workflow prompt designed to be reusable in a pre-commit setting. The key instruction is to create a workflow that not only includes the necessary commands, but also explains the purpose of each command, what output we should expect at every step, and guidance on handling any failures that might occur. This kind of detailed prompt helps ensure clarity and reliability in automated processes, making it easier for developers to maintain consistent standards and catch issues early. By specifying these elements, we can build more robust applications and automations while streamlining our development workflow. In this lecture, we focus on creating reusable command workflows that streamline your development and automation tasks. One key approach is converting your workflows into scripts, which makes them easy to run repeatedly and adapt as needed. Depending on your environment, you can use different scripting options. For instance, Bash scripts are great for shell environments, especially on Unix-based systems. On Windows, PowerShell scripts offer powerful automation capabilities integrated with the system. For cross-platform needs, Node.js scripts can run consistently across various operating systems. Python is another versatile option, widely used for automation due to its readability and extensive libraries. If you're working within JavaScript projects, npm scripts provide a simple way to manage repeatable tasks. Lastly, makefile commands serve as a classic method to define and execute build workflows. By converting your workflows into these script formats, you create repeatable, maintainable, and efficient automation processes that save time and reduce errors. When designing a reusable workflow, there are several key qualities to keep in mind. First, it needs to be clear. Each step should be obvious and easy to follow so that there's no confusion during execution. It also needs to be repeatable, meaning the process works consistently every time it's run. Safety is crucial, so any risky action should be limited, carefully checked, or reviewed to minimize errors or issues. Documentation is another critical element. This includes recording commands, the purpose of each step, and how to handle failures, ensuring that everything is transparent and accessible. The workflow should be easy to run. Another developer should be able to execute it without running into confusion. Finally, it should be easy to modify, allowing updates and improvements without needing to rebuild the entire process from scratch. These principles form the backbone of an effective, reusable workflow that stands the test of time. Hooks are a powerful concept in development, so let's break down what they really are. Essentially, hooks allow us to trigger actions at specific points within a process. This means you can run custom code either before or after certain events occur, giving you the flexibility to modify behavior right when it matters. Another key function of hooks is that they help enforce rules. By inserting checks or validations at critical moments, you can ensure that processes comply with your desired standards. Alongside this, Hooks play a big role in supporting automation control. They enable automated workflows to react and adapt dynamically based on the events happening in the system. Finally, hooks are especially useful for developer workflows. They streamline tasks and create more efficient, manageable code by embedding these conditional actions. Overall, hooks act as strategic control points that make advanced coding and AI integration smoother and more responsive. Here, we're looking at some common use cases for hooks, which are essential tools for automating and enforcing best practices in development workflows. First up, pre-commit checks are crucial. They help catch issues early by running validations before changes are committed. This ensures that only clean, error-free code makes it into the repository. Next, code formatting hooks automatically adjust code to a consistent style, saving time and preventing style conflicts across the team. Test running hooks are another powerful use case. They execute tests automatically, confirming that new code doesn't break existing functionality. Security scanning hooks add an extra layer of defense by checking for vulnerabilities or unsafe code patterns before anything is merged. Logging activity is important for transparency and auditing, so some hooks track and record actions taken during the development process. Lastly, blocking risky actions with hooks helps prevent potentially harmful changes, like pushing sensitive data or deleting critical files, from being executed. All of these use cases demonstrate how hooks can streamline workflows, improve code quality, and enhance security, particularly when combined with advanced technologies like Claude Code and AI agents, which bring even more automation and intelligence to these processes. Now, let's review the essential hook safety rules that ensure our automation runs smoothly and reliably. First, keep hooks small. When hooks are single purpose, they're much easier to trust, debug, and maintain, which reduces complexity overall. Second, avoid destructive actions within hooks. That means no silent deletes, resets, or any dangerous system changes happen behind the scenes. Transparency is key here. Third, always log what happened. Clear output is crucial because it helps developers understand exactly what ran, what failed, and why, making troubleshooting far more efficient. Fourth, allow overrides carefully. Manual bypasses should be rare, very explicit, and well documented, so they're only used in true emergencies, protecting the integrity of the automation. Finally, test before team use. Validate hooks on sample files first to prevent unexpected failures, and keep the team's workflow smooth and predictable. These rules help us build controlled, reliable automation that developers can work with confidently. Today, we're focusing on using hooks for controlled automation. This approach helps ensure that automation tasks happen exactly when they should, under the right conditions, and with safeguards in place. The process begins with careful planning before implementation. First, you define the trigger, essentially the specific event or condition that will start the hook. Next, you specify the checks to validate that everything is as expected before the hook proceeds. These checks are crucial because they prevent errors or unintended actions. Then, you set the failure behavior, which determines what should happen if those checks don't pass. This might include halting further automation or triggering an alert for manual review. The prompt here guides us to design a safe hook workflow by clearly explaining when the hook runs, what checks it performs, the commands it uses, and what the failure outcomes are. Breaking it down, we have three main components: the trigger point, the validation logic, and the failure path. By following this structure, you create hooks that not only automate tasks effectively, but also maintain control, safety, and reliability throughout the process. This method leverages advanced Claude code and AI agents to bring precision and intelligent decision-making to automation workflows. On this slide, we have a hook implementation checklist designed to guide us through controlled automation. The first key step is to understand the trigger point. Knowing exactly when and how the automation should start is crucial for smooth operation. Next, we review the commands to ensure they are correctly defined and will perform as expected. Testing on sample files comes after that, which helps us verify that the automation behaves properly before full deployment. We also confirm any error messages that might appear, so we can handle exceptions gracefully. It's essential to document all setup steps clearly to maintain consistency and support future troubleshooting. Finally, Sharing this information with the team ensures everyone is aligned and ready to work with the new automation tools effectively. This structured approach helps us implement automation in a controlled and efficient way. Let's talk about why maintaining discipline with Git is so important. First, it protects our project history. By carefully managing commits and branches, we keep a clear record of all changes, which is essential for tracking progress and understanding how our code evolved. Second, it makes changes traceable. Every modification is linked to a specific commit and user, so we always know who made what change and why. Third, it helps us undo mistakes. If something breaks or wasn't quite right, we can easily revert to a previous stable version without losing valuable work. Fourth, Git discipline supports collaboration. When multiple developers work on the same project, a consistent workflow prevents conflicts and confusion, making teamwork smoother and more efficient. Finally, it makes AI coding safer. Since AI-generated code can sometimes introduce unexpected issues, having a disciplined Git process ensures that any problematic changes can be tracked and reversed quickly. Altogether, these points highlight why following a structured Git workflow is a cornerstone of effective software development. Here, we're looking at a recommended AI coding Git workflow designed to keep Claude-assisted changes manageable and reliable. The key idea is to follow a controlled sequence. This ensures every change is reviewable, testable, and easy to reverse if needed. We start by creating a branch dedicated to the new changes, which isolates our work from the main code base. Next, we inspect the plan proposed by Claude, making sure everything aligns with our goals. Once satisfied, we approve the plan, signaling readiness to move forward. The next step is applying small, incremental changes rather than large, sweeping modifications. This makes it easier to identify issues and maintain control. After applying changes, we run tests to verify that everything works as expected. With passing tests, we then review the diff to closely examine what exactly was modified, ensuring no unintended changes have slipped in. Finally, we commit the changes, solidifying them in the code history. By rigorously following this safe sequence, we maintain high code quality and traceability when leveraging Claude and AI agents in our development process. Here, we're focusing on how to review stage changes and craft clear commit messages using conventional commit style. This approach helps maintain consistency and clarity in your version history. With Claude, you can simplify this process by turning your stage diffs into clean, well-structured commits. This not only saves time, but also ensures your commit messages follow best practices, making collaboration and code review much smoother. Using advanced AI agents like Claude in your Git workflows helps automate and improve the quality of your commit messages effectively. When preparing a pull request, it's important to make it as clear and comprehensive as possible before anyone starts reviewing the code. A strong pull request should explain the change itself, the validation has been done, and any remaining risks. This way, reviewers can understand the context easily and focus on the quality of the code. Here are the key elements to include. First, provide a summary of the changes made. Next, explain why the change was necessary, what problem it solves or improvement it brings. Then, list the files that were modified so reviewers can quickly locate them. Be sure to describe the tests you performed to validate your changes. If there are user interface updates, include relevant screenshots to visually demonstrate what's different. Also, highlight any risks or limitations associated with a change, so reviewers are aware of potential issues up front. Finally, include a sign-off to confirm that the pull request is ready for review. Following this structured approach makes the review process smoother and more effective. To help with this, tools like Claude can draft the pull request structure for you. However, it's crucial that you personally confirm all facts, test results, and potential risks are accurately represented. This ensures the quality and clarity of your submission from start to finish. Before making the final commit, it's crucial to follow a checklist to ensure everything is in order. First, check your branch to confirm you're working in the right place. Next, check the status to see what changes have been made. Then, review the diff carefully to understand exactly what will be committed. Running tests is essential at this stage to catch any errors or issues early. After that, write a clear and descriptive commit message that explains the changes you've made. Once you're confident, Push your changes safely to the remote repository. Finally, if necessary, create a pull request to initiate the review and integration process. Following this workflow helps maintain code quality and smooth collaboration. In this section, we're diving into GitHub Actions. Essentially, GitHub Actions are automations built right inside GitHub that help streamline your development workflow. They can be triggered by specific events, like pushing code or opening a pull request. Once triggered, these actions can automatically test your code to catch issues early, build your projects without manual intervention, and support continuous integration and continuous deployment processes. This means you can automate much of your development pipeline, making it faster and more reliable. With GitHub Actions, you're not just automating simple tasks. You can create sophisticated workflows that enhance productivity and ensure code quality throughout your development cycle. Let's go over some of the common use cases for GitHub automation that can really streamline your development process. First, running tests on pull requests is a crucial step to ensure that new code integrates smoothly without breaking existing functionality. Next, building the project automatically after every push helps catch issues early by verifying that the code compiles and behaves as expected. Checking formatting is another valuable automation. It maintains code consistency and helps teams adhere to style guidelines without manual effort. Generating reports can provide insights into code quality, test coverage, or deployment status, making it easier to track project health. Automating the labeling of issues saves time in organizing and prioritizing tasks by categorizing them based on predefined rules. Finally, deploying code automatically after approval ensures that new features or fixes get released promptly while still maintaining control over process. These automations, combined with advanced tools like Claude Code and AI agents, empower developers to build smarter apps, automate routine workflows, and enhance overall productivity. Before creating the YAML file for your GitHub Actions workflow, it's crucial to plan the entire process carefully. First, define the triggers. These are the events that will kick off your workflow, like pull requests. Next, establish the checks you want to run, such as running tests and verifying code formatting. Once you have this plan solidified, you can ask Claude, an AI assistant, to explain each step of the workflow in detail. For example, you might prompt Claude with something like, create a GitHub Actions plan for this project. It should run tests on pull requests, check formatting, and explain each workflow step before creating the YAML file. This approach combines thoughtful planning with AI assistance to ensure clarity and effectiveness before you dive into the actual code. When it comes to pull request reviews, Claude steps in to make the process much more efficient. It helps reviewers quickly identify the most important quality signals before they approve any changes. For example, Claude highlights which files have been changed, so you know exactly what parts of the codebase are affected. It also points out potential risk areas, allowing you to focus on sections that might need extra attention. Additionally, Claude flags missing tests, which is crucial in ensuring your code is well covered and reliable. It can also detect possible bugs, helping catch issues early before they make it into your main branch. Documentation gaps are another key area Claude reviews, ensuring that any new code is properly documented to maintain codebase clarity. Lastly, Claude provides a summary of the pull request description itself, making sure all critical details are captured and easy to understand. By combining advanced Claude Code and AI agents, this tool streamlines the review process and boosts confidence in your code quality. Let's focus on the GitHub automation checklist, which is essential for creating effective and secure workflows. First, ensuring the correct trigger event is crucial because it determines when your automation will run, avoiding unnecessary or premature executions. Next, using the correct commands is vital for your scripts to perform the desired actions accurately. Protecting secrets is another key point. Your sensitive information like tokens or passwords must never be exposed, so always use GitHub Secure Storage for them. Clear failure messages help you quickly understand what went wrong, making troubleshooting much easier and saving valuable time. Running workflows on the correct branch ensures that changes are tested or deployed in the right environment, preventing confusion or conflicts. Lastly, avoiding accidental deployment is fundamental to safeguard your production environment from unintended changes. Keeping these points in mind helps build robust, reliable automations that streamline your development process while maintaining security and clarity. Release documentation plays a crucial role in the development process for several reasons. First, it clearly shows what has changed in the latest update, making it easier for users to understand the new features or fixes. This transparency helps users stay informed and adapt quickly. Additionally, release documentation is valuable for clients as it allows them to review the work done and ensure it meets their expectations. From a team perspective, it enhances communication by keeping everyone on the same page regarding progress and modifications. Finally, maintaining thorough release documentation creates a professional record of delivery, which can be referenced in the future for accountability and continuous improvement. All of these points together emphasize why documenting releases is essential for successful project management and user satisfaction. Let's talk about the difference between change logs and release notes. A change log is typically a technical list that's mainly developer focused. It's a detailed record of every change made to the software, like bug fixes, updates, and improvements. Its key purpose is to provide a clear and concise history for developers or technical users who want to track what's been altered in each version. On the other hand, release notes are designed to be more user-friendly. They focus on the value and impact of the changes from the end user's perspective. Instead of just listing changes, release notes explain how those changes benefit the user, highlight new features, and sometimes include instructions or important information. This helps users understand why the update matters to them and how it improves their experience. Understanding this distinction is crucial when communicating updates effectively to different audiences, whether you're addressing your development team or your customers. Here, we're looking at an example of a changelog prompt designed to make updates clear and organized. The key idea is to first ask for a structured format. This ensures that the changelog is not only easy to read, but also simple to review and ready for any release documentation. The specific prompt example asks the system to review recent Git changes and categorize them into distinct groups like features, fixes, refactors, tests, documentation, and known issues. By grouping changes this way, it becomes much easier to understand what was added, what was improved, and what outstanding issues remain. This approach leverages advanced AI tools like Claude Code and AI agents to streamline the development workflow, making your app building, automation, and documentation process more efficient and effective. Here's an example of a client report prompt designed to translate technical work into language that clients can easily understand. This is especially useful for freelancers, agencies, and internal teams who need to communicate their deliverables clearly and effectively. The prompt might say something like, convert this changelog into a short client-friendly report explaining what was done, why it matters, what was tested, and what is recommended next. This approach helps turn raw, technical changelogs into business-facing updates, making it easier for clients to grasp the impact of the work, understand the testing performed, and know the recommended next steps. It's a practical way to bridge the gap between complex development details and clear client communication. In this slide, we're focusing on the release documentation checklist, which is essential for any professional software release. A well-crafted release document should clearly outline what is shipped in the new version, highlighting new features that users can expect. It should also detail any fixes made, along with technical changes that might affect how the software operates or integrates with other systems. Equally important is a section on tests completed, which reassures stakeholders that the release has undergone thorough quality checks. The document should also honestly present any known issues that haven't yet been resolved, so users and developers are aware of potential risks. Finally, it should outline the next steps, guiding the team on what needs attention moving forward. This structured approach ensures transparency, helps manage expectations, and supports smooth transitions between development cycles. Log analysis is essentially the process of reviewing system output to gain insights into how an application or system is performing. First, we look at logs to find any errors or warnings that might indicate problems. This helps us understand where failures are occurring and why. By detecting patterns in the log data, we can identify recurring issues or unusual behavior that might not be obvious at first glance. Overall, log analysis supports faster debugging, allowing developers to quickly pinpoint and resolve issues, improving system reliability and performance. With advanced tools like Claude Code and AI agents, this process becomes even more efficient and insightful. When we're working with logs, it's important to remember that logs by themselves don't tell the whole story. For better analysis, we need to provide context around them. This means including details like what system was running at the time, what specific action triggered the issue, and the exact log output you observed. It's also helpful to note any recent changes that may have contributed to the problem, as well as relevant environment details. Finally, clearly stating the expected behavior helps differentiate between normal operation and actual issues. By giving logs this kind of context, tools like Claude can better separate symptoms from likely causes, making the troubleshooting process much more efficient. This approach is especially powerful when combined with advanced Claude code and AI agents. Here, we have a log analysis prompt designed to help us make sense of complex log data. The goal is to analyze the log systematically by grouping related errors together, which helps us identify patterns rather than isolated issues. Next, we focus on pinpointing the likely root cause, distinguishing it clearly from the symptoms that might look problematic but aren't the core issue. Finally, based on this understanding, we recommend safe and practical next steps to resolve the problem effectively. This approach not only streamlines troubleshooting, but also ensures we address the underlying issues rather than just the surface symptoms. When dealing with incident response, it's crucial to use a consistent report structure. This helps ensure that incidents can be thoroughly analyzed, properly fixed, and valuable lessons can be learned without any guesswork. Start with an issue summary, clearly explaining what happened, where the problem appeared, and how it was first detected. This sets the stage for understanding the incident at a glance. Next, create a detailed timeline. Document all key events from the moment the first symptom appeared to the verification that the fix worked. This helps trace the progression and response steps. Then, assess the impact by identifying which systems were affected, how users were impacted, what business risks were involved, and the severity level of the incident. This gives context on the urgency and scope of the issue. After that, determine the root cause. It's important to find the underlying reason behind the symptoms, not just a visible error, so that the problem can be addressed at its source. Document the fix applied, specifying corrective actions taken, whether it was a rollback, patch, or a change in workflow. This clarity helps when reviewing what was done to resolve the issue. Finally, develop a prevention plan. This might include monitoring improvements, testing protocols, updated documentation, or changes in processes aimed at reducing the chance of similar incidents happening again. By following this structured approach, issue summary, timeline, impact, root cause, fix, and prevention, you help your team learn from every incident, communicate more professionally with clients, and continuously improve the reliability of your systems. Here's a helpful checklist to guide us through the incident workflow process. First, we start by collecting logs. This step is crucial because logs provide the raw data we need to understand what happened. Next, we identify the impact, determining how the incident affects the system and our users. Then, we work on finding the root cause, which is essential to prevent the problem from occurring. After that, we apply a safe fix, something that resolves the issue without introducing new risks. Once the fix is in place, we verify the system to ensure everything is functioning correctly. Finally, we write a summary documenting the incident, our findings, and the steps taken, which is important for future reference and continuous improvement. This structured approach helps maintain control and clarity throughout incident resolution. Let's talk about why tool connections are so important. First, code typically resides in repositories. This is where developers store and manage their programming work. Data, on the other hand, lives in various systems, which could be databases, cloud services, or other platforms designed to handle information. Tasks are usually organized on boards, such as project management tools, making it easier to track progress and assignments. Reports generated from these activities are then shared with clients and teams to keep everyone informed. For automation to truly be effective, it needs to operate within a safe workflow that ensures accuracy and security. That's where advanced Claude code and AI agents come into play. They help streamline and integrate these elements seamlessly, creating a more efficient and reliable process. On this slide, we're focusing on the different types of external tools commonly integrated into developer automation systems. These tools are crucial because they allow developers to streamline workflows and enhance productivity by connecting various aspects of the development process. First, we have GitHub, which is widely used for version control and collaboration. APIs play a vital role by enabling different software components to communicate and interact seamlessly. Databases are essential for managing and storing data efficiently across applications. Local files provide a way to handle data and resources directly on a developer's machine. Project management tools help teams organize tasks, track progress, and maintain clear communication. Documentation systems are key for maintaining clear and accessible information, ensuring that everyone is on the same page. Automation platforms tie all these elements together, enabling developers to automate repetitive tasks and build complex workflows. Additionally, advanced tools like Claude Code and AI agents are becoming increasingly important. They help build applications, automate processes, and create smarter developer workflows, boosting efficiency and innovation in software development. In this lecture, we're focusing on security and permissions, with a strong emphasis on the principle of protect before you connect. This means that before you establish any connections or integrations, you need to ensure that sensitive information is tightly secured. Key elements of protect include API keys, which are like digital passwords that give access to your services. Access tokens serve a similar role, granting temporary permissions that must also be safeguarded. Database credentials are crucial because they control access to your stored data, and if compromised, can lead to major breaches. Client data must be protected vigorously to maintain trust and comply with privacy regulations. Protecting private repositories is equally important to prevent unauthorized code access or modifications. Lastly, user information is perhaps the most sensitive, requiring encryption and strict access controls. By focusing on these protections up front, you help prevent security vulnerabilities and ensure that your applications and users remain safe throughout any interaction. Before connecting any external system, it's crucial to start with a clear plan. This means defining key elements like permissions to control access, the data flow to understand how information will move between systems, and identifying potential security risks to keep everything safe. You also need to decide on a thorough testing approach to ensure the integration works smoothly and have a rollback plan ready in case anything goes wrong. A useful way to approach this is by designing a safe integration workflow specifically tailored for your project and the tool or API you're connecting to. This structured planning helps minimize risks and ensures a seamless, secure connection. Before connecting Claude Code to any external system, there are 6 critical controls we need to confirm to ensure security and functionality. First, define the purpose clearly. Understand exactly why you're making this connection and what you want to achieve. Next, limit permissions strictly. Only grant access necessary for the task to minimize risks. Protect secrets diligently by securing any sensitive information like API keys or credentials. Always test with sample data first to verify everything works correctly without risking real data. Logging actions is crucial for monitoring and troubleshooting any interactions. Finally, document the entire setup thoroughly so that anyone involved can understand the configuration and controls in place. These steps will help maintain the integrity and safety of your integration with Claude Code. In this section project, our main goal is to build a reusable developer automation system. This system is designed to streamline workflows and tasks that developers frequently perform, saving time and reducing errors. The key deliverables for this project include a complete workflow, a set of commands or scripts, possibly implemented as a GitHub action, and thorough documentation to ensure ease of use and maintenance. Our focus throughout this project is on creating automation that maintains safety by including human control points. This ensures that while processes are automated, developers can still intervene when necessary to maintain oversight and prevent unintended consequences. Additionally, we will be incorporating advanced Claude Code and AI agents to enhance the system's capabilities, making the automation smarter and more adaptable to different development scenarios. This approach aims to bring together automation efficiency with controlled human oversight, striking a balance that supports developer productivity and reliability. Now, Let's focus on the project section where you choose one automation to design, test, and document. There are several options to consider here. First, the pre-commit check, which helps ensure code quality before it's merged. Next, the test automation script, which streamlines testing processes. Then, the changelog generator simplifies keeping track of changes in the project. The PR description generator assists in creating clear pull request explanations. Log analysis automates the review of logs to spot issues quickly. The release report option compiles release details efficiently. Finally, advanced Claude code and AI agents provide more sophisticated automation capabilities. Each option offers a unique benefit, so selecting the right one depends on your project's needs and priorities. For a strong automation submission, you need to include all 7 required deliverables. This means you can't just submit the script alone. Instead, you need to provide the full context and controls that make your automation safe, testable, and reusable. These deliverables include the automation goal, the detailed workflow steps, the actual commands or script, safety checks to ensure reliable operation, test results to prove it works, thorough documentation, and clear manual approval points where human review is necessary. This approach not only demonstrates the purpose and process behind our automation, but also ensures transparency and control, meeting the project standards fully. Always remember, a successful submission shows both the problem you're solving and how you maintain safety and oversight throughout. Here, we have a suggested sequence of Claude code prompts designed to guide you smoothly from identifying tasks to implementing safe automation. It starts with identifying repeated developer tasks within a repository, which helps pinpoint where automation can have the biggest impact. Next, you design a safe automation workflow, ensuring that any automation you create aligns with best practices and safety standards. Once the plan is approved, you move on to creating the actual commands or scripts to perform the automated tasks. After that, it's crucial to add clear documentation so that anyone interacting with the automation understands its purpose and usage. Finally, you conduct a thorough review to identify potential risks and failure cases, making sure your automation operates reliably. Following this plan, build, and verify flow ensures a structured approach to building effective and safe developer workflows. Before submitting your automation project, it's crucial to go through this final checklist to ensure everything is in top shape. First, make sure you only ship the automation after confirming safety, clarity, and reusability. The automation should work reliably under expected conditions, and all commands must be safe to execute without causing errors or unintended consequences. You should also have handled potential failure cases to avoid disruptions. Comprehensive documentation is essential so users can understand and maintain the automation. Don't skip a manual review to catch any overlooked issues. Lastly, the automation should be designed with reusability in mind, making it easy to adapt and extend for future projects. This checklist helps guarantee a robust, effective solution built with advanced tools like Claude Code and AI agents for creating seamless workflows and applications. We've now completed Section 3 and are fully ready to move forward with AI agents. At this stage, you build a solid foundation for professional automation using Claude Code. This includes mastering terminal workflows, creating reusable command systems, maintaining strict Git discipline, managing release processes effectively, preparing for incident response, and planning the safe integration of external tools. Throughout this section, we've emphasized developing an automation mindset, implementing control workflows, and ensuring safer delivery systems. These elements are crucial for building reliable and scalable automation solutions. Looking ahead, the next section will dive deeper into advanced topics such as AI agents, sub-agents, the multi-channel prompt system or MCP, developing skills, SDK workflows, and designing safe agent architecture. This will take your automation capabilities to the next level by combining the power of Claude Code with intelligent AI agents.